So in this particular class, we will be using Python and the Google Colab. Python, I hope all of you have installed yesterday in your local. That is pretty much needed in your upcoming classes. But today, in today's class, we'll be utilizing only Google Colab. So what you will be learning today? High level plan for the next 3 hours, for the upcoming 3 hours would be, first we will talk briefly about why Python became the main language for AI ML. Then we will cover core Python basics you need for data and ML, like variables, lists, dictionaries, control flow, functions, these kind of things. Next we will meet the key ML libraries like NumPy, Pandas, Matplotlib and Scikit-Learn. We will move into Google Colab, which is a hosted Jupyter notebook environment from Google. So everyone can run Python in the browser with 0 installations. Like you no need to install VS Code, you no need to install Anaconda, you no need to install Jupyter Notebook, nothing needs to be installed. Just on the fly you can use Google Colab and you can call it a day. Finally, we will build 2 small ML projects together. I planned 2 ML projects. One is an iris flower classifier. Second is a study hours versus exam score regression. So in one, I'll be showing how to do a classification project. And in the second, we will be doing a study hours versus exam score regression, a regression model. So we are going to do 2 things. If you follow along and run the code with me, you will walk away with 2 working notebooks you can reuse and modify later. So whatever the project that I'll be doing today, you can extend it. That will be the assignment at the end of the class. I will do the project till a bit, and then after that you will be extending the project and you will be doing some things on your own. That is how the assessment will work. Okay, and just as a note, before we jump in, who here has written any Python before, or who here have not written any Python before, who have not used Jupyter or Colab before? Any one of you have like never written a Python code in your life? Okay, yeah, got it. So I will start from a very basic, like what is Python, and we will go from there. Okay, so yeah, we'll be going from the Python basics now, like what is Python and why we use Python, and we'll be going from that level. Okay, let's start with the quick motivation. Why Python? Like yesterday, this point came up, like why we use Python. Actually, before starting this, anyone any doubts still here on what we'll be doing in this class? Okay, yeah. So yesterday this point came up, like why we use Python instead of using any other programming language like R or Java or C, C++, Ruby, whatnot, Cobalt. There are a lot of programming languages, and in fact you can code in them. Like you can code, you can code actually AI and ML in Java if you like. You can actually do that, but doing that would be very hard. But doing that would be very hard because you won't be having all the required libraries supported in those particular languages. Why only Python is because Python is consistently at the top of the charts for data science and machine learning in both industry surveys and job postings. Monish, why only Python? R also can do a very good data handling. So one of the main reasons why we use Python and R is Python and R are very good at data handling. Every programming language has its pros and cons. Example, take C. In C, you handling actual code is much more powerful, but you cannot handle variables and you cannot do object oops approach. You cannot do it in C. C++ can do that. C++ can do the object oriented approach, but it has a problem with garbage handling and all. Then came Java. Java can do garbage collection in a very efficient manner, but it cannot handle data properly. So then came Python. Python is written on top of C. On top of C++. Python is considered to be the slowest programming language. If you can also search in internet. One of the fastest programming language is C++, and one of the slowest programming language is Python, because Python is written on top of C++. Whatever you write in Python gets compiled to C++, then it gets compiled into your computer. So there is a mid-level of C++ whenever you are using Python. But the main advantage of using Python is very terribly good at data handling. And your AI/ML is all about data handling, so that is the reason we use Python. That is first point. Second point is R also can do that. Programming language R can also do data handling efficiently. Then why not R? Why only Python? Because the number of jobs and the number of developers who are using R are very low. They are very, very, very minimum. The number of developers who are using Python and the number of job postings that are available for Python are too high. So that is the reason we, in this particular course, we have picked Python as our main programming language to handle AI and ML. And again, it is consistently on the top. I'm not saying like it is only on the top in 2023 and 2022, not like that. From the over the period of 2020 till now, till 2026, if you look at the charts and surveys, Python is consistently at the top of the charts for data science and machine learning in both developer survey and in job postings. And some of the few big reasons are: the syntax is very readable and concise. Anyone who is not aware of Python, anyone who is not aware of programming languages can pick up Python in a very fast manner. It's very easy to learn programming language. The syntax is readable, it is very concise, and Python code tends to look like a pseudocode. More of than like a programming language, Python code looks like a pseudocode, which means you can spend more brain power on the ML ideas and less on wrestling with the language. So that is the reason all the developers who starts in ML and AI picks up Python as their programming language. And the ecosystem of Python is insanely rich. It is insanely rich. NumPy for arrays. For array handling, you have NumPy. For data, you have Pandas library. For classical ML, you have Scikit-Learn. You have PyTorch and TensorFlow for deep learning. You have different libraries for every single use case in Python. In regards to AI/ML, again, most ML tutorials or courses or tools that you find in internet assume you are using Python. They all assume that you are already using Python. You go and search for any, like if you go and search for a model creation in YouTube, you will find thousands of videos in Python and only one or two in R. That is how popular Python is, even in the YouTube community or in the course community. That means if you know Python, you can plug into almost any new framework or paper code base. You can plug into yourself into any kind of course, any kind of environment. Okay. So Python in one single slide. Again, few more things about Python before we go into code and before we actually do the practical things. First of all, let's get into a very definition of Python. Python is a very high level and interpreted programming language. Monish, what does this mean? What is a high level programming language mean, Monish? Let's take a few examples of a low level first. Let's see what does a low level programming language looks like, so that you will understand what is a high level programming language looks like. Okay, you see this, right? 8x hyphen 64 machine code. This is a low level programming language. The one you see here, we call it assembly programming language. And usually in BTech computer science, we come across this assembly programming languages. If you have ever seen a chip, an actual chip design, we actually code assembly programming languages in that chips. All the chips that you see, like the microchips and all, they all rely on this assembly language. Any one of you, can you, I mean, without looking at the comments, would you be able to read this and tell me what it does without looking at the comments? It's very hard, right? Maybe if you already know assembly language, if you give me like 30 minutes or 20 minutes of time, maybe I can say what this programming language does, but it takes a lot of time and effort. That is the reason it is called as a low level programming language. Low level programming languages are the languages that are not easily understandable by humans. They are easily understandable by computers. They are not easily understandable by humans. This is an actual programming language. The one that you are seeing here is an actual in real life programming language that are used in microchips. And if you want to go into microchip design and all, you have to learn assembly language. Otherwise you cannot survive there. All the Intel, AMD, NVIDIA processors all use this assembly programming language, and it is one of the hardest programming languages to learn because it is a low level programming language and it is very hard for a human to read it, but for computers it is very easy to understand it. Computers get difficult in understanding high level programming languages because high level programming languages are designed to be understandable by humans. It is like English, it is like plain English. Right on the right side you can see that name, course, lesson, print, welcome name, this is class, course. You can, I mean, but if you just know plain English, you can derive something of this language. You can understand, okay, name is Monesh, course is this, lesson is this, and print means, okay, maybe the programming language is printing something, and it says welcome, okay, name means Monesh is substitute. You can derive something out of it. That is what a high level programming language mean. High level programming languages are easily understandable by humans and difficult to understand by machines. Lower level programming languages are the reverse. It is harder to understand by the humans and it is easy to understand by the computers. And what does this interpreted mean? Interpreted mean like the computer understands the code line by line, line by line. So the computer first reads the first line, it understands something, then it goes to the second line, it understands something, then it will go to the third line, it understands something. If a programming languages is executed line by line, then we call it interpreted programming language. In other terms, if you see Java, not Java, good example would be C. If you take C or C++, they are called compiled languages because all of the code is compiled at a time. You don't compile Python, you interpret Python because Python is converted to C++ as a middle level. So Python is a high level programming language. It is an interpreted programming language. You run files or notebook cells, you don't compile them. Again I say, you don't compile Python, you interpret Python. And it's dynamically typed. Monesh, what is this dynamically typed language, Monesh? You don't have to declare anything. You don't have to declare anything. If you see here in this code, I never said anything. I have never written let name, const name, variable name, or integer name, or something like string name. I have written nothing on the left hand side of name. I have just written name. And name equal to Monesh, lesson equal to 2 and all, and it automatically understands that name is a string and lesson is a number. It itself understands it. So what I'm trying to say is, you no need to spoon feed everything to Python. Python is a very intelligent language and it automatically understands lot of things without you telling it. So that is one more advantage of using Python. Python is a dynamically typed program language. You don't have to declare types. The interpreter figures them out at runtime. Next, it is widely used, not just for ML, but also for web backends, automation, scripting, DevOps. In lot of these places also Python is widely used. And the most important part for us is Python gives us enough power to build serious ML systems, but with a gentle learning curve. Let me show you what I'm talking about. To put that in practice, I'll show you something. Let's take a JavaScript compiler. See, now I'm saying JavaScript compiler. I'm not saying JavaScript interpreter. I'm saying JavaScript compiler, C compiler, but I don't say Python compiler. Python is interpreter. But while typing in internet, you type it as Python compiler. It became a habit for everyone, but that's the case. Let me show you the difference on how other programming languages work and this one. Oh my god, it's creating a project folder. So this is a simple JavaScript code that I'm writing here. If you see here on the left side of the name, left side of the name, I'm writing let. I'm writing let. Actually, I think it is better to show you in Java rather than JavaScript. In JavaScript, at least you write let, const, and var and all. In Python, you no need to do that. But let me show you a Java code. Yeah, you see, I have written string name. I have written string name. Now let me show you something. You see, now I change it to integer. I'm specifically saying that int name means in Java, in terms of Java, int name means the name has to be a number, not a string. So that is the reason you are facing an error here. Because Java is not dynamic as Python. Java is not so intelligent as Python. If I do the same thing in Python, first of all, you don't declare variables. You don't say int Python, int name, string name. You don't do all those kinds of things. You just write name. Name equal to some string. You can put number. You can put something like I can put name equal to 6, and I can just print name, and this works fine. Yeah, you see, it got printed. So what I'm trying to say is, in Java or in the other programming languages that I just shown now, they all require some or the other kind of declarations and everything for their variables. Like int name won't work. Int name Monish or int name those kind of things won't work in Java. But the same things works in Python. This won't work, because I specifically said as name to be an integer. If I put it as string, and suddenly this will work fine. Oh, indentation, I mean semicolons are mandatory in Java. This is one more headache. Yeah, you can see it is working now. If I change it to int, in Java it won't work, but in Python it is very less code, and also it is very dynamic. That is one more thing I wanted to prove. Automatically it understands whether the name is a string or a number or something. Type of, oh sorry, my bad, it's not type of. Yeah, you can see here it is a integer class. I've never mentioned it, but Python automatically has taken it as a integer class. So yeah, these are all the things on why we use Python, and that is what Python is. Python is a high level programming language. It is an interpreted programming language. It is a dynamically typed language. It doesn't require any semicolons, those kind of stuff. Just white spaces and indentations define the entire blocks, used for backends, DevOps, ML pipelines and all. And it is an excellent choice for first language in AIML. Any doubts in Python? Like what is Python and why we use Python? Still I will go. I'll tell you what is data types of Python and all, because I'll be going from a very low level of Python. So I'll be still teaching that. But yeah, any doubts in why we use Python and what is Python? Anyone? Okay, but yeah, feel free to ask me if you have any doubts. Okay then. Next is data types and variables. Till now I was talking like int, string, float and all, right? Monesh, what is this data types, Monesh, and what are these variables? Why we need to learn all this stuff? Data types and variables are like ABCDs in your Python. Like how in English language we have A, B, C and D and alphabets that combine together to form sentences, words, and then the words are combined together to form sentences, right? That basic stuff in Python is your data types and variables. They combine, yeah, the data types and the variables, they combine, and there is also something called keywords. They all combine to give you a good syntax. So first let's talk about data types. Data types is nothing but anything that defines data, like whether the data is an integer. Integers means 0, 1, 2, 3, 4 numbers. All the numbers are denoted as integers. Then what is float, Monish? Float means 0, 0.01, 0, 0.2, 0, 0.3, 1.1, 1.2, 1.5. You see the decimals, right? All the decimals are floats. All the actual integers are your integers, like zeros, 1, 2, 3, 4. No decimals. Non-decimals are integers, decimals are your floats. Simple as that. And usually we use numbers for counts and continuous values in Python. So we have integers and floats for numbers, strings for text, booleans for true or false. Variables are just names pointing to these values. They are just values. Sorry, they are just the names that are pointing to these values. Now let's see how it works. Let me copy this simple code. Go to our Google Colab and let's paste it. So we have an age, which is a number, so it is denoted by integer. Let me zoom in, and also I got a feedback that the PPT that I'm presenting is a bit hard to see, so I'm zooming in. Yeah. So the age is an integer. The learning rate is a float because it is a decimal. As you can see, it is 0.01. The course is a string because it is in English. It's just English sentences and all, AI and ML. And is beginner is a boolean because it has only two values, either true, you can put it true, or you can put it false. Both are valid boolean values. So you can put true or false. So now let's print it. And in Google Colab, if there is a shortcut for running the cells, okay. Let me get one step back. These are called cells in Google Colab. You see this box, right? This one block is called a cell. CELL, cell. This is called a cell. If you want to run a cell, all you have to do is click in here and do shift plus enter. Shift plus enter, and it will execute. The same thing I'll be doing again, shift plus enter. It got executed. Now you can see here when I printed age, 24 got printed. When I printed learning rate, 0.01 got printed. Course, AIML got printed, and is beginner, true got printed. The left side things you see here, right? Is beginner, course, learning rate, age. These are called variables. These are called variables. And variables are nothing but your names, your name. My name is Monesh. That is my variable. Your name may be something. That is your variable. So our names are the variables, because that is how I call you. That is how I define you. If I want to call you, I won't call like hey black shirt, hey pink shirt. We won't call in such a way, right? We call by names. Those names are nothing but variables in Python. If I want to call 24, I won't say hey 24. I will call it with the variable assigned to it. I will call the age, and automatically 24 gets printed. So that is how variables work. Variables are names. They are the actual names pointing towards the values. So I hope all of you understood what are variables and the values and what data types in Python mean. You don't define any data type in Python. You never say you don't write integer, you don't write float, you don't write string, you don't write boolean. Automatically it gets understandable by Python. And Monesh, what are this green color, Monesh? What is this green color things that are on the right side? What is this symbol and all? So you see this symbol and the things that I write, right? These are called comments. These are called comments. COMMENTS, comments. Python will never execute comments. They are simply there for your developers, and they're simply there to make the code more understandable. You put it, you don't put it, it doesn't matter at all. I remove it also, it doesn't matter. I can remove it and I can still run the code, the output will be the same. Comments are not for the machine. Comments are for the humans. We write comments so that the next developer who works on the project, for him to make the code more understandable, we put comments here and there. And there is no specific guidelines for putting comments. Some developers put comments in every line. Some developers put comments only on the top of the functions. Some developers never put any comments. Some developers put all the comments in the readme file. So there is no one particular structure on how to use comments. It is up to the developer's choice on how they want to write comments. There is no specific guidelines or rules that are assigned to that comments have to be in this particular manner. So I'm putting comments back because I'm sharing this Google Colab, and it will make you understand this code much more easier. So yeah, before moving forward, any doubts, anyone, on what are data types and variables in Python? All good. Okay. But yeah, please free to ask me. The main agenda of this entire course or classes is to make you understand. If you are not understanding in any place, please let me know. Let's move next thing. Yeah. Once after you knowing about data types and variables, the next thing that you have to learn is lists and tables. Okay. In how, again, I'll take an example to English language. After you learning ABCDs in English, in ABCD Z to Z in English, what is the next thing your teachers taught you? What is the next thing you do? You try to form words with it. Like you will pick A and you will pick two P's, P, and you will pick one L and you will pick one E. You will put them all together and you will say apple. APPLE, apple. Or you will say something like CAT, cat. What you typically do is you try to put alphabets together and you try to create a word from it. The same thing happens now. Now you have variables with you. Now you have data with you. Data in the sense your values. Now the next thing you have to do is creating lists and tuples. Lists are nothing but collection. Lists are nothing but collection of a mutable ordered anything. It can be anything. It can be any data type. An ordered mutable strings, an ordered mutable integers, an ordered mutable floats, an ordered mutable collection of lists and an ordered mutable collection of strings and numbers. It can be anything, but it has to be ordered and mutable. Monesh, what is ordered? What is mutable? Ordered in the sense it is having a specific order. It has to be in a what is the right word to use? Like one after other. Let's say one after other. You have to put the numbers in one after other in a lined manner. In a lined manner, you will be putting one number after another number, or one string after another string. If you put it in an order in a specific line, it may be sorted, it may not be sorted. It can be in ascending order, it can be in descending order, and it may not be in both. It may be randomized numbers also, but it has to be one after other forming a single line kind of structure. That is called an order. That is called an order. And mutable collection in the sense you can rearrange the line. You can rearrange the line in the sense you can append, you can insert, you can modify, you can sort. You can do all of these things to a list. To a list. Example, let's go to whiteboard. List. In list you have something like 2, 3, 6, 4, 1, 8. This is an ordered mutable collection. Why I am saying ordered mutable is because the numbers are in a line. You see one number is after another number. So we call it as an order. And next, why I am calling it as mutable, because I can do anything with these numbers. I can do anything with these numbers. I have the power to do anything with these numbers. For example, I can bring 4 in the middle of 2 and 3. Like I can say 2, 4, 3, 6, 1, 8. I can do this. I can suddenly change this 3 to 5. I can do something like 2, 4, 5, 6, 1, 8. So what I'm trying to prove is I have immense power on this particular order. I have immense power. Think of this like a line formed for some buying iPhones. Let's say these are the people who are lined to get iPhones, and let's say I am the security guard there. Now I have the power to rearrange the people. For example, I did not like this person. Okay, I can come to this person and I can bring him to the last. I can bring him to the last in the line. And for example, I like this person. Let's say he bribed me something, and I like this person. I can bring him to the first of the line. I have immense power there. That is called a list. That is called a list. A list is a collection of numbers or array, numbers or strings or anything. It can be a mix also. It can be something like 2, Monish, Neuralin, A, 6. It can be a mix. It doesn't matter. That's what I wanted to prove. It can be a collection of data types as well. It doesn't matter. But I have the immense power to move anyone any place. That is called a list. A list is an ordered mutable collection. You can append, insert, modify and sort the entire list that you have here. Then what is tuple, Monish? Tuple. Tuple also, let's take the same example. Tuple also ordered. Tuple also ordered. 2, 3, 6, 4, 1, 8. Tuple also ordered. But here the problem is, again, take these are the people who are lining up for buying iPhones, or in any phones, and I am the security guard, but the owner is very strict here. The owner of the shop is so strict, and it doesn't allow me to rearrange the people. Even if I like someone, I cannot bring them front, and even if I don't like someone, I cannot bring them to the back. I have power, but I cannot do anything because the owner is very strict there. So that is tuple. Tuple is also an order, but it is immutable. Once you create it, you cannot change it. There is no way you can edit it. That's all. You create it, it's done. The line itself is in that manner. No one can touch the line. It will be going in a very systematic manner. So there are different use cases when to use list and when to use tuple. When you create a order, and if you know that you have to rearrange them, then you will be using a list. And if you know that you should not rearrange the people, then it is a tuple. So simple. A list can be rearranged, tuple cannot be rearranged. So lists are everywhere in machine learning code. Lists of metrics, lists of feature name, lists of models you want to try. They are everywhere. In real work that we do, if you're trying multiple models, you might store their validation accuracies in a list just like this, and then pick up which is the best one out of all of that. And let me show you this code. Again, all the green colors that you see here are comments. They are not executable. They're just for your understanding. So now we have a list here. Actually, one more thing maybe. One more thing is, lists are always denoted by square brackets. Whenever you see something like a square brackets, understand that they are lists. Whenever you see normal brackets, like a curved brackets, they are called tuples. Tuples are denoted by curved brackets. Square brackets are denoted by lists. So these are lists and these are tuples. So if you see here, this is denoted by a square bracket. So automatically in your mind you have to understand that it is a tuple. Accuracies here is a tuple. So what I'm doing is I'm using a for I comma acc in enumerate accuracies comma start comma 1. What I'm indirectly saying is I'm looping through this tuple and I'm printing each one of them. I'm looping through the tuple and I'm printing each one of them. And here acc.2f means after the decimal I will be using two floating points. Let's run it. See, model and I. What is I? I starts at 1. So I starts from the first place is taken as 1 here. So it takes as 1. It takes as 1. And the first value in the tuple is 0.82, that gets printed. Next 0.88, next 0.91. And since I'm doing .2f, it is printed as 82, 88, 91. Now let's see what happens if I put 1f. Only one value after the decimal is getting printed. And if you see, observe closely, here 0.88 becomes 0.9. 0.88 becomes 0.9. Why? Because 0.88 is very near to 0.9 rather than 0.8. So that is the reason 0.88 has become 0.9. And you have to be very careful when using this .2f and .1f. You may think that what is the difference between 0.88 and 0.9, but that 0.02 will change your entire model's accuracy in the longer run. When you're doing the model creation and when you're calculating the accuracy, this miscalculation of 0.02 will change the entire accuracy of the model. So you have to be very careful when you're using .2f, .1f and all. You have to know when to use what. Here My suggestion is don't use .2fs and .1fs. That is my suggestion. Leave it as it is. Because if you don't leave it as it is, the 0.02s and 0.01s will accumulate, and it will change the model's accuracy in future classes. But I'm just showing you that it is possible to do that. So yeah, that is a list. As I said, square brackets are denoted with square brackets are denoted by lists, and open brackets, I mean these curved brackets are denoted by tuples. You can also print a tuple. You can also print a tuple. 4.0, 8.0, that gets printed. So any doubts in lists and tuples, anyone? And Niveda, I think you are new to Python. You're getting this right, or any doubts in it?
Yes, I understood, but I would like to confirm the list is denoted by square brackets, right?
Yeah, list is denoted by square.
Okay. Okay. Yes. Yes, I get it.
Yeah.
Thank you.
Oh my bad. So yeah, lists are by square brackets and tuples are by curved brackets. Next. The next that you will be learning is about dictionaries and sets. These are a bit different from lists and tuples. Dictionaries map keys to the values. These are perfect for configs. In future you will be seeing config files. So these are perfect for configs, label maps, or experiment metadata. For example, a dictionary for model config might include model, n neighbors, test size, and access is config of n of neighbors. So when you're doing a model building, right, you will be using a lot of config and you will be putting a lot of parameters. All of this will be possible by using dictionaries. I'll give you the example of a dictionary. And also sets. Coming to sets are also like dictionaries, but sets are collection of unique values. They are set of unique values, very handy when you just want to know which distinct labels exist in your data set. So now let's see the code in Google Colab. If you see here, these are just numbers, but these numbers are not assigned to any values. Like all the numbers have only one assigned type called accuracies. And here one more thing that I forgot to mention is you can also access individual values here. For example, if I want to print only 0.88, I want to print only 0.88, I can just do something like print of accuracies, and I can say 1, and I run it. You get 0.88, which means that your index, your value starts from 0 in any list or tuple, it doesn't matter. Your calling always starts from 0. The first place is always 0. If I do 0 here, you get 0.82. So the first place is always denoted with 0. You can just say accuracies of 0 and the first number is printed. If you say 1, the next number is printed. If then the next spot is 2. So 0, 1, 2. The same for even tuple as well. If I say simple range of 1, you get 8.0 because it starts with 0. And if I put 0 here, I get 4.0. I get 4.0. And you can ask me, Monesh, then why here you're saying start equal to 1 and the first number that is getting printed is 0.82, because here I'm specifically saying to start with 1. The model I has to start with 1. If I, for example, if I put it as 2, and here it starts with 2, this whatever the start value that I put here is not for this ACC, it is for this I value. It is for this I value. So that is the reason it's the start, whatever the parameter I say start, it is for the I value, not for the ACC values, not for the accuracy values. Yeah. Okay, coming to dictionaries. So here in the dictionaries, you can assign any value to a key, something like variables. How you put variables like a equal to 2, name equal to Monesh, class equal to 8, like how you put those values, the variables to values. The same thing in dictionary, every value will have a key, but instead of calling it as a variable, we call it as a key. And instead of using an equal to sign, we will be using this colon symbol. So model is KNN, n neighbors is 3, test size is 0.2. Now if you want to call KNN, you will be calling model. Like for example, if I want to call you, how I will be calling with your name. The same way, if I want to call the value of KNN, I will be calling the model. So if I say config of model, KNN will be printed. If I call config of n neighbors, the value 3 will be printed out. Now let's test it. You see KNN and the 3. So config model calls out KNN, config n neighbors calls out 3. You cannot simply call model. This won't exist even. You cannot simply call model. The Python code won't understand. You have to call it by using config of model, because inside config there is model. Config of n neighbors. And next comes, and that is your dictionaries. That is how dictionaries work. Dictionaries have a key and a value pair. Next is your labels. Sets. These are called set. Set. And sets are nothing but the extension of a we call tuple. You can say extension, not tuple, extension of a list. It is an extension of a list, because what are square brackets denoted for? Square brackets are denoted for a list. This is a list. Labels is list here, because you are using square brackets. And I forgot to mention, dictionaries uses flower brackets. Again, just as a note, so that you won't get confused. List uses square brackets. Tuple uses open and closed brackets. Dictionaries uses flower brackets. Set uses set of and the tuple. It will be called in this manner. For example, if you see in the code, set of and the labels. What are labels? Labels is nothing but a tuple. So you will be calling with set of and the actual tuple inside it. So list square, tuple curve brackets, dictionary flower brackets, set is set of list. So you have initialized a list, and you have called it as set of list. Set of list will give you the unique values inside a list. Automatically all the duplicates will be removed. For example, here in the list you have duplications. 1 is duplicated, 2 is duplicated. Now when you converted it to a set, automatically all the duplications are removed, because set can only contain unique values. Sets are a collection of unique values, very handy when you just want to know which distinct label exists in your dataset. So as you can see here, when you do set of labels, automatically that 0 1 1 2 2 2 is converted to 0 1 2. And there is one more useful feature. My screen get turned off. Yeah. So yeah, there is one more important feature when you're learning about lists, tuples, dictionaries, and sets. That is length. Print len of anything. You can call labels or you can call unique labels. Let's call labels and do print of unique labels. If I do run, you can see here print of length of labels is 6, whereas print length of unique labels is 3. Here len denotes for length. Length of the list, length of the list, length of the tuple, length of the dictionary, length of the set. Here when I called length of labels, labels is tuples. You can count 0, 1, 2, 3, 4, 5. When you are starting with 0 and if you are going till 5, the actual count is 6. If you count from 1, 1, 2, 3, 4, 5, 6. So that is the length of list is 6. If you count the unique labels is after removing the duplicate values. After removing the duplicate values, you have only 3. 1, 2, 3. So that is why the length of unique labels is 3. So that is your list, tuple, dictionary, and a set. Any doubts still here on these 4? List, tuple, dictionary, and a set.
I have a question to ask.
Yeah.
So let's take you're mentioning how we are taking the labels and figuring it out, like what are the unique labels. Is there a way how we can figure out like how many times it's repeating? For example, how many times 1 is repeating, how many times 2 are repeating?
For that again, you cannot directly do it from a set, but you have
Okay.
to write a code for it, and you can find out like for of I, and you
Okay.
can put a count variable and we can count it. But when converting to set, we cannot directly find it out.
Okay. Gotcha. Thank you.
Yeah,
I have a doubt.
yeah.
So I see where we use the dictionary sets, length, and stuffs, but where do we use list and tuples in practical world?
Sorry, Niveda. Where do we use?
Yeah, where do we use list and tuples?
Okay. Uh, for example, in when you're creating a ML model, let's say, you can put something like models, and we will be doing something like model 1, model 2, model 3. This is one way that we'll be doing it. You have 10 different models, and if all the 10 different models you have to put it in one single variable, we'll be doing this. Or else, let's say you have a data set, and in the data set there are 5 columns like age columns equals to age, name, roll number, marks, and class. So this is one place during dataset extraction we'll be using list in this manner. Tuple also in the same manner. Instead of using a list, you will be using a tuple if you know that you will not be rearranging the columns.
Okay, I think I understood.
Yeah, when I import a CSV or an Excel sheet, we'll be
Mm-hmm.
using list only there for showcasing all the data.
Okay.
Yeah.
Okay. Thank you.
Yeah, and for this also storing predictions, metrics, feature names. For all of this, we use either list or tuples based on the use case. Okay, and the next is control flow and functions in Python. Okay, so control flow is how you tell Python what to do when something happens, like use if, elif, else for branching, use for loops to iterate over lists or arrays, use functions def to package reusable logic. That accuracy function is actually very close to what scikit-learn does internally when computing accuracy, comparing true and predicted tables, count how many matches divided by total we do. All of this that we will be doing in the further classes, the basis of all of this is this control flow and functions. Let's see some code for it. Mm, l- mm, number equal to or else age equal to 18. We have a variable called age equal to 18 and we can control the flow now. Let's say you are creating an app where the minors are not allowed and only the people who are above age 18 are allowed, only majors are allowed, let's say. Then you can define something like if age is less than 18, if age is less than 18, then print you're not eligible to vote, something like it. Or else if age equals to 8 exactly 18, then say that mm, let's say there is a state where only 19 years of ages people can vote. You can say something like uh, please visit next year to vote, and then finally else, and you can say you are eligible to vote. Now let's do input of okay. So what I did here is I've created a simple code logic that takes inputs from the consumer, inputs from the customer. Now let's say we are asking for the age. Actually, let me print that as well so that we'll get more context. We will say yeah. So we are asking the customer to enter his or her age. So please enter your age. Let's say my age is only 12. Oh, for okay, here there is a one more problem here that I forgot to mention. Usually, when you give input, right, this input, you have to mention what kind of data you will be taking in. Or else it will be considered as a string instead of a number. So you have to specifically say whether it is an integer input or it is a string input. Otherwise, the Python will not know whether the input is a string. I mean the same 18. It doesn't know whether it has to be considered as a string or whether it has to be considered as a number. So now when I specifically said int, automatically that string 18 will be converted to number 18. Now if I give, let's say 12, it says you are not eligible to vote. Again if I run and if I say exactly 18, it will say please visit next year to vote. Now if I run it and if I say something like 26, it will say you are eligible to vote. So now what we are doing is, based on the customer's input, we are controlling the flow of the code. We are deciding what to execute and what to not execute in the code. That is called a control flow by using if, elif and else. Any doubts in this? Okay. Now let's see for loops, which we'll be using so widely when going to ML code. Let's take a list. Let's take these columns. Okay. This is a list because they are using square brackets. Now if I say something like, now my use case is I have to print all the columns. I have to print all the columns in a neat fashioned manner. I can simply do like for I or for call in columns, print col. Now Monesh, columns is okay. Columns, you said it is a list variable and you created a list and you have named it as columns. What is this col, Monesh? COL. What is this? This is a temporary variable that I am creating for the for loop to contact these columns. This can be anything. I can put it as an I can put it as a K, I can put it as Monesh, my name. It doesn't matter. You can put any name here. That, so I have put COL, but whatever the name that you are using here, it has to match with everything that you are moving forward. If I put I here, you should change this also to I. If I put K here, you have to put this to K. So whatever you put on the top, it has to match with the inside functionality. So when I do for K in columns, print K, now see what happens when I do shift plus enter. Automatically all the columns are printed out in a neat fashion manner. This is possible by using a for loop. For loop is nothing but we are saying iterate over the list, iterate over the tuple, iterate over the dictionary, iterate over the set. You can use a for loop to iterate on anything. So for K in columns, print K. So it will first go to age, it will print it. Next it will go to name, it will print it. Roll number, print it. Marks, print it. Class, print it. And it can be anything. I can just say I can put I, same output. Nothing will change. But whatever you use here, you have to use it here as well. That is the catch. So that is your for loop. Any doubts in for loop on why we use for loop? Okay. Next, finally, def. Def means function. Okay, why do we use def, Monish? What is the use of a function? For example, let's take there is a piece of code that you have a lot of use case to. For example, let's take this simple function of adding two numbers. Def means definition. The full form of def in Python is definition. Def, this sum is called the function name. It is called a function name, and sum can be anything. You no need to write only sum. You can write your own name as well. It does not matter. You can give any name to it. You can give any name to it. It does not matter. And the values inside this brackets you see here, right? I'll zoom in a bit. The values that you see here, right, they are called parameters. They are called parameters. What is a parameter? For example, to run the engine, to run the car engine, you need petrol, right? To run the car engine, you need petrol. So to run it, you need something to be provided to it. To run it, you need something to be provided to it. For example, if you are, I think that is the good example I can think of. If you want to cook something, and if you want to light that gas cylinder that comes out gas, right? If you want to light that, you need gas inside that gas cylinder. So there you are providing something to run it. Here also, I need to provide these two parameters called a and b, two values, to run this function, to run these functions. Without these two values, this function will not work. It will throw an error, because these two values are being used inside. If you see inside Monesh, there is a print of a plus b, and we are using it. Let's say I'm not using b inside, then there is no use of you sending b. You can only send a. There is no point in sending b, and you can remove it. But since I will be using two variables inside, I have to get those two variables when this function is getting called. And I'm doing print a plus b, which are just printing two numbers. Now how do I call it? I will simply call it with its name, the function name. I'll change it back to sum of 5, 6. Sum of 5, 6. Now I will run it. I get 11. So we have created a simple calculator that can add any two numbers. Now here, if you see properly, why do we need a function for this? I can also simply do print 5. I can also do like this, right? Print 5 plus 6. I can simply do this. Then why am I calling sum of 5, 6? Do anyone know the answer? Like, why do we use a function? If I do this also, I get the same result. Print of 5 plus 6 is 11. And sum of 5 plus 6 is also 11. 5, 6. Why do we use a function then? Anyone, any idea on why we use a function?
Maybe when you want to add more features to your function, so you want to define it.
Exactly.
Let's say if you want to add a condition or something, so if you define the function, it will be easier.
Exactly. So if you want something to be executed for n number of times, I mean there is something that you will be using for again and again and again, and also if you want to improve that something with some extensions, then that something becomes a function. So now whatever you can update this function, like for example, instead of only doing print a plus b, you can add more features to it. Print a star b, print a minus b, print a divided by b, and now you can simply make the sum to be a calculator. You can simply make it into a calculator. Now with just by using cal and providing two numbers, like let's say 6, 5, you have created a simple calculator. Now you provide two numbers and automatically it will be doing addition, subtraction, multiplication and division. That becomes much more easier, right? Now again you can extend it. You can call this to different numbers now. Like you can call for 7, 2. You can call for 9 comma 3, you can call for 10 comma 1, you can call for 2 comma 6, and suddenly everything becomes so simple now. So you're just calling it with two numbers and the function is already defined. The function is already defined. If whatever the numbers you provide, it will do addition, multiplication, subtraction and division. So instead of writing code again and again and again for every number, you will be writing a functionality at a time and you will be calling that functionality with different numbers. The same thing applies to cars, car engines and every product that you use. This is the same functionality that is being engineered. You take a car, you take a simple car, let's take a Honda. In Honda there are different models, but what they do is they take the same engine, they will be updating that engine with multiple components and they'll be putting it into a different modeled car. So here using the functionalities becomes much more easier than creating everything from scratch. Imagine you have to create every engine from what do we call, instead of reusing the same structure of every engine, if you have to create every engine with again doing research work, doing lot of technical, doing lot of thinking around an engine to build it from scratch, you can simply use the same model of a different car. You can update that engine to with more components and you can just re-release it with a new branded model. The same thing happens for iPhones, the same thing happens for every mobile. The same structure, the same model functionality with different components, different functionalities attached to it, and they call it for the next year release. So that is the use of functions. Functions are nothing but a blueprint that can be used by any different given parameters. So yeah, any doubts in control flow or functions? Okay. Before going to this mini example, I just want to really know if all of you got it right till functions, because next things will be a bit. They will be diving into a bit of NumPy, Pandas, and all, where ML concepts come into place. So I just wanted to confirm. Uh,
Yes, it is clear now.
Clear, right? Okay, okay. But yeah, please, if anyone have any doubts, please do let me know, because the coming up topics will be again the complexity of the things starts to increase now. We will be going into NumPy and Pandas. They are so related to ML now, so the complexity is going to increase. Okay, so coming to a simple mini example, a simple grading logic. I'll tell you why we are getting this error. This is also something you have to know. First of all, what we are doing here, we have some scores. Let's say I'm a teacher. Let's say I'm a teacher in a school. Now there are only four students, or else four students have given the exam. The first student got 52 marks, the second student 67, 81 and 93. And this is a list. So the principal asked me to grade the students, and he has given me a rule that if anyone scores greater than 90, greater than or equal to 90, then I have to put them in a grade A. If anyone scores greater than or equal to 75, I have to grade them B. If greater than or equal to 60, it is C. If nothing on the top, then it is D. So, but let's say I'm a very lazy teacher and I don't want to grade every one of them individually, I mean manually. So I have written a code. I have written code and I have given all the scores as a list. Here, one thing if you notice, the grade alif else, they all are in red color. They all have a small red color bar on the bottom. You know why? Because of a problem called indentation. You will find this indentation problem in Python, and especially in Python, because the structure of Python is defined by the white spaces and indentation. Monish, what are you talking? What is this indentation again? You see this if, right? After this if I just press enter, you see where my cursor is, I mean where that blinking pointer is. It's not exactly at the bottom of I, it's exactly at the bottom of F. If you look closely, I'll do zoom. If I do something like B, or I type something, it is exactly at the bottom of F, but not at the bottom of I. You see this white space here, right? This is called indentation space. And indentation space is so important in Python. That is what defines the entire block. And without proper indentation, your entire Python code is obsolete. Your entire Python code is useless. It won't work. So you have to make sure that you are always using proper indentations. So how do you use proper indentations? So simple. Just if you have a doubt at any point in your code, just click on at the end of those lines and press enter, and see that the next line is matching or not matching with the indentation. Here it is not matching, because if you see G is at the bottom of I, but grade equal to A should be inside if condition. So what I simply do is I come to G and I do a backspace, and then I do a tab. That will fix it. Or else there is one more simple fix. If you don't want to do that, there is one more simple fix. Just go to, just press enter here, and in your keyboard you will see a delete key. Just click on those delete key until the grade comes to that place. That's all. And automatically the red tint will be gone. Do the same thing for the others as well. Click on enter, click on delete. It came to that cursor, leave it. Next do for this thing, delete. It came to the pointer, leave it. Next do for else, it came to the pointer, leave it. See, automatically that fixed the entire code. So indentation and white spaces are very much important in Python programming language. Now here, what does this code does? So for S in scores, so we are iterating through scores, and if S is greater than or equal to 90, we will be putting A. If it is greater than or equal to 75, we are going to put B. Greater than 60, C. If nothing in this ABC, then we'll be going for D. Now let's run it. You see, score 52. The first one is score 52. 52 is greater than or equal to 90? No. It is greater than or equal to 75? No. It is greater than or equal to 60? No. So since all of these three conditions fail, suddenly 52 will be mapped to D. Grade D. 67 is greater than 60, so C. 81 is greater than 75, so it is B. 93 is greater than 90, so it is A. So that is how this code works. A simple example for grading logic. And the same kind of rules we will be using in machine learning eventually, where the data, we instead of hard coding scores, we will be using on the actual data. And this is an example where we'll be using list, actual lists. Lists and tuples are very widely used in ML. Any doubt till here? Okay, So it's 4:30. I mean, it's 1.5 hour once that we started the session, and let's do a small recap till here, and we'll take a short break. So we started with Python and Google Colab. I have explained you what is Python and why we have picked Python for this machine learning. I have explained you what is Python, the definition of Python, and why Python is used, data types and variables in Python, and how it is a dynamic typed language, what is integer, float, string, and boolean, and how variables are used for data types. We have seen lists and tuples. Any order with the square brackets is list, curved brackets is a tuple. And list is mutable, which means we can rearrange it. Tuple is immutable, which means we cannot rearrange it. Then we have seen dictionaries and sets. Dictionaries uses key value mappings, and it uses flower brackets. Sets also uses square brackets, but they have contain only unique values. They contain only unique values. Next, we have seen control flow and functions, the uses of if, and else conditions. We have also seen for loops, and we have seen a mini example of a simple grading logic. So that is what we have learned so far, and let's take a short break of 20 minutes. We'll meet back at 4:50 CST, and we'll continue with libraries inside ML, NumPy, Pandas, Scikit-Learn, and all. So yeah, in the meantime also, if you have any doubts, please do let me know. See you all after the break. Around 30. So yeah, we are back after the break. I hope all of you are back too.
I'm back.
Yeah, thanks for coming, Kamala. So yeah, let's start the next half of the class because there are a lot of things to be covered. Uh, yep, I think we can cover. Okay, so coming once after you learning the basics of Python, the next thing that we'll be dive into is, I mean, there are a lot of things inside Python that we have to cover, but again, this is not a Python course, so I'm not delving too deep into Python. In Python, again, there are a lot of things. There is file handling and lot of except exceptional handling stuff and all, but I'm not delving into that. I'm delving into Python where it is necessary for AI and ML. So the core libraries. Okay, first of all, I have to tell you what is a library in a Python. A library in a Python is where we will be taking someone else's code. The things that I'm going to talk like NumPy, Pandas, Scikit-Learn, Matplotlib, these are all modules, functionalities inside Python that are written by great developers. They have written it and they have put it out for free. Anyone can use their code. So what we have to do is we have to just import their functionalities, import their codes into our programs. So in that way, there are few core libraries like NumPy, Pandas, Matplotlib, Scikit-Learn. These four are the famous, most widely used libraries for machine learning. So let's tackle one by one. Let's talk about NumPy. Yeah. So NumPy, now let's layer in the tools that makes Python truly powerful for ML. NumPy gives us multi-dimensional arrays and fast vectorized math. Wait. Monesh, what is this array? Till now you are talking about lists, tuples, dictionaries and sets. Suddenly where this array came into place? Arrays are nothing but lists. In other programming languages, whatever I have shown it as list, we call it as arrays in R or in Java, in C and C++. The name of that list is called an array. But in Python, the developers who have created Python, they have named it as a list. That's all. Lists are simply arrays. Arrays are simply lists. Instead of arrays, you can simply call it as fast lists and vectorized math. Nothing is going to change. So just for naming, I'm calling it as an array because that is how NumPy calls it. So when NumPy calls it as an array, we call it as an array. So NumPy gives us multi-dimensional arrays and fast vectorized math. Instead of writing Python loops, we can do operations over entire arrays in one line. We can do entire operation of in an array in just one single line. How? Monish, how do we do it? Suddenly you're saying operations, you're saying we can do it in one line. How do I do all of this? Very simple. Let's go to Colab. Let's create a simple list. Like take this 1, 2, 3. Okay. Let's say IDs equal to 1, 2, 3, 4, 5, and the names, actual names is not required, just take IDs for now, or else let's take scores. Okay, let's take scores. And let's say I'm a very friendly teacher to the students, and the students behaved so well in the course, in the class, and as a gratitude I wanted to give everyone plus 5 marks. Okay, as a gratitude I wanted to add plus 5 marks to every single student. So how do I do this? I do it by for s in scores, uh, add +5 to all the scores. So this is how I do it. So for I in range of length of scores, scores of I plus equal to 5. So when I run this code, 52 plus 5 is 57, 67 plus 5 is 72, 86, 98. So for every single number that you see here, every score +5 is added. If you want to add +8, you will be doing plus or equal to 8 and a +8 will be added. This is one way of doing it by using a for loop. But the problem is in Python, in traditional Python, this is fine. But if you are talking in machine learning, there will be thousands of scores, there will be 1 lakh of scores, and using a for loop is a problem there. Why? Because for loop adds more time complexity into your programming code, and time complexity increasing the time complexity is never a good thing. So using a for loop for 1000 rows and 1 lakh rows creates a problem there. So for that, NumPy, we use NumPy. What do we do here? We call import NumPy as NP. We import NumPy as NP, and it's record again. We call import NumPy as NumPy, and we say or else I'll use the same code. Let's put this scores here. By using NumPy. Oh, it has given. Okay, scores equal to np.array numpy.array of scores. That's right. Scores equal to scores plus 5, print of scores. Yeah, that works. So what we are doing here, we are simply converting np.array of scores. So we are converting this list that is here into a NumPy array. We are converting the list into a NumPy array. Converting list to a NumPy array. We are converting a list to a NumPy array, and then we are adding +5. Now if I run it, it's the same output, 57, 72, 86 and 98. But doing this becomes much more easier. If you look at both the codes, you can look at it and tell me, like, if there are a very big array like a 10,000 rows or a 1 lakh rows, automatically using a for loop, putting scores of I plus or equal to 5, range, length, scores, instead of doing all these kind of things, you can simply just convert to np.array, and you can do +5, +6, into 2, into 3, whatever operation you like, and everything will be done automatically for you. That is the use of using NumPy. NumPy gives you multi-dimensional arrays and fast vectorized math. Every math that you give it, it is so fast when compared to for loop. Instead of writing Python loops in this manner, we can do operations over entire arrays in one single line. In just one single line, you can do an entire operation over an array. So that is how powerful NumPys are. This matters because, Monish, why are we using NumPy then? This matters because machine learning often deals with vectors and matrices, which I'll be showing. We will be dealing with vectors and matrices, feature vectors, weight matrices, embeddings, etc. So for all of this, performing operations using a for loop takes lots and lots of time. So by using NumPy, we can reduce time complexity of those operations. and let me run this code, this entire code. Yeah. So you can see that we have added the X array and the Y array, and the output is 5, 7 and 9. So 1 plus 4, 2 plus 5 and 3 plus 6. So we have added two different arrays and we have printed the output. And this is the dot of x comma y. Dot of x comma y is that in mathematics there is dot matrix where we will be multiplying two different matrices. So the dot product of two different arrays is 32. So any doubts still here? And if you want to know how this dot product is calculated, it is simple. It is 1 into 4 plus 2 into 5 plus 3 into 6. So 4 plus 10 plus 18 gives you 32. That is how dot product works. Multiplying the similar numbers and adding each of them. 1 into 4 plus 2 into 5 plus 3 into 6 gives you 32. So what I wanted to prove is any kind of mathematical operations can be easily done on arrays using our NumPy. NumPy is very good at handling arrays. Any doubts on NumPys? Okay. And NumPy is also the backbone of Pandas, Scikit-Learn and deep learning frameworks that we are going to learn. So when you have to use NumPy, whenever you're working on lists, always remember to use NumPy. If you find a list, just use NumPy for ML. Next is Pandas. Pandas is very good at handling data. Pandas is how we work with tabular data. Think rows and columns like Excel, but programmable. Most machine learning datasets you will touch in the beginning, like CSV files from Kaggle, database exports. For all of this, Panda is perfect. So, Manish, what are you talking about? Let me show you. So, one example that I've shown you is with with list, because it has a squared bracket. So this is one of the example where lists will be using. Lists are nothing but your arrays that will be converting using NumPy. Coming to Pandas, Pandas heavily rely on dictionaries. Pandas heavily rely on dictionaries. Let's take this one. We have a data dictionary with hour submitted to be some values and score to be some values. Okay. So now our goal is we have to describe it. We have to get to know more about this data. How do we get to know more about this data? In traditional Python, there is no way. There is no way you can get more information from this dictionary. You cannot do that. So for that, you will be using a library called Pandas. Import Pandas as PD. Okay, here one more thing you have to observe. Monish, why are you using only NP, import NumPy as NP? Why not a different value? Yes, you can use any value. You can use your own name. It doesn't matter. It will still work. But the catch is whatever you use here, you have to use it everywhere. The output will still be the same. But it is a common practice that NumPy is denoted with NP, Pandas is denoted with PD. It's a simple common practice in coding. So now simply how do I convert this dictionary into a Pandas data frame is df, again a variable, equal to PD, which stands for Pandas dot data frame of this data. Simple, that's it. Automatically your data dictionary is converted to a Pandas data frame. When you do np.array, your list is converted to a NumPy array. When you're doing data frame of data, your dictionary is converted to the Pandas data frame. Now you can do any number of things because the Pandas has lot of methods in it. There are lot of tools in it. One more important feature of Panda is df.describe. You will be using df.describe a lot in machine learning. In every single project we do, we will be using df.describe, because df.describe will give you a clear cut knowledge on the data that we will be using. You can see the count of hours studied. It is 4. 1, 2, 3, 4. You can see the mean. You can see the standard deviation, minimum 25%, first 50%, first 75%, the max. You can see the score also. Count is 4. What is the mean of the score? What is the standard deviation of the score? What is the minimum of the score? All of this in a neat, clear-cut fashion. All the data will be described to you in a neat tabular format. This is one of the very useful feature in data frames. I mean in Pandas, DF. DF stands for data frame. And again, it is a normal variable. You can put your own name also, it doesn't matter, but it's a coding practice to put it as DF. And one more important method is df.head. df.head. df.head will give you the first 5 values in a neat tabular format. df.head. There is also df.tail. So I mean there are a lot of methods, like there is df.mean, df.min, df.max. Later, I mean when the class is going on, we will be loading the iris dataset. We will convert into a data frame, and we will be converting it using Pandas at that time in that project that we will be doing in few minutes. So any doubt in Pandas? And one more thing is NumPy, Pandas, Matplotlib, Scikit-Learn, these all have n number of methods, n number of features. Because of the time constraints, I cannot show you all of them. But during the projects, when we will be doing projects, right, I have incorporated all of those methods into different projects. So no worries. Every project that we do, if we will be I will be showcasing some or the other methods in NumPy, Pandas, and in these different libraries. I've designed the projects in such a way so that you will be covering all the methods of Pandas, NumPy and all, because they have lot of methods, df.min, max and all. So any doubts in Pandas or NumPy? Why we use, what are they, what are their use cases? NumPy is for converting list to an array and using mathematical operations. Pandas is for converting data to a data frame and doing lot of functionalities. Any doubts, anyone? Okay. Yeah. The next is Matplotlib. Before training models, we want to see a relationship between different columns. When I use the word see, what I meant by see? For example, as a developer, I can understand this table. Now, as a senior ML engineer, I can understand the table, I can see the relationship between them. But what about junior developers, or what about clients who don't know about this tables, datas and all? Clients don't like this kind of numbers and all. They like visualization part. They like to see the things instead of understanding the tables and the technical things. So visualizing data is an incredibly important task in an ML engineer's life. Before training models, you want to see the relationships between them. Like, is there any roughly a line? Are there any clusters? Are there any outliers? So what are the relationship between different columns? Are there any values that are too deviant, too spread? So you want to see a lot of things in the code, in the data. And the one library that makes it possible is Matplotlib. Matplotlib is a standard plotting library. Other libraries like Seaborn built on top of it. There is also a library called Seaborn, which I'll be bringing in projects. But Matplotlib is the basis of all the visualizations part in Python. So we'll see one of it, how it will be used. Let's copy this code. Let's paste it here. And I hope I've shared this link of Google Colab, and whenever I do something here, it will be updated in that Google Colab that I shared. So we imported Matplotlib dot pyplot. This is important part. Till now you have just imported Pandas, you have imported NumPy directly, but Matplotlib is a very huge library. It is a very huge library, and we don't want the entire Matplotlib. We just need only part of it. So in the Matplotlib, we need only the pyplot of it, only the pyplot subversion of Matplotlib. So Matplotlib dot pyplot as PLT, something you can alias, it's an alias, you can put any name here. Now I say plt dot figure of size 4,3. I'll tell you what this 4,3, or else actually I'll run it and I'll execute for a better understanding. Yeah, so here 4,3 means the plot size at the bottom takes fourth the width, and the proportionality of the vertical will be 3. So it's not an exact square, but the figure of size is bottom it will be 4 parts and the top it will be only 3 parts. Vertically it will be divided into 3 parts and the bottom to be 4 parts. That's what the figure size mean. You can also change to different values that you like 8,3, and you will see the difference. So now what happened? The x-axis took 8 parts, the y-axis took 3 parts. 3 parts of height and 8 parts of width. That is what 8,3 mean. So 4,3 is better, so I'll change it back. Yeah. So plt.scatter data frame of hours studied. From where this data came? From the top. Data.hours studied. Hours studied is mentioned on the x-axis here. Hours studied. Comma df score. Score is mentioned on the y-axis, on the vertical section. So if you see, what is the first data? The one data is 50. 1 represents 50. So the first one is 1 and 50. It is pointed here. What is the second one? The second one is 2, 60. So 2 and 60. Next is 3, 65. Let's see. 3, 65. Correct. Next is 4 and 80. 4 and 80. Exactly right. So that is how the plots are scattered. And that is how it's pointed. And the color you give here is the color that is shown here, the blue. Next is plt.xlabel, hour studied. It is the naming that we give to the x-axis. You can give it anything that you like. Y-label means the naming that you give for the y-axis. Plt.title is the title that is shown on the top. Study time versus score, the one that is shown on the top. And finally plt.show will showcase the output. These are the different things that are there in Matplotlib. 90% of the time we will be using only these things. There are also a lot of things involved, but only plt.figure, scatter, x-label, y-label, title, show. These 90% of the time we will be only using these. And Matplotlib is used to plot the values in a visualization aspect. Any doubts on Matplotlib? Not only a scatter plot, there are a lot of plots in it, and during the projects I will show you. There is also a pie chart, there is also a line chart. There are a lot of plots that you can plot with Matplotlib. As an example, I have just shown you scatter. Any doubts in NumPy, Pandas or Matplotlib? Okay. Next is Scikit-Learn. Scikit-Learn is our workhorse for classic machine learning. Monesh, why we use Scikit-Learn? What happens if we don't use Scikit-Learn? If you don't use Scikit-Learn, you have to write every single algorithm that you want to use in machine learning. You have to write your own code. You cannot get the code from anywhere. By using Scikit-Learn, you no need to write the algorithms. You can just use the algorithms. So what Scikit-Learn does is it includes lot of algorithms like regression, classification, clustering, and pre-processing. It has a very consistent API. You fit on training data, then predict on new data, and use metrics to evaluate the model. The pattern is almost always choosing a model. The pattern always will be choosing a model, creating an instance with hyperparameters. We will be using fit x of train and y of y train. We will be using a method called predict on x of test. Then we will be evaluating those metrics. Every single time this will be your case. When I just copy and run this, you won't get anything. If I copy it and I paste, you won't get anything. You see, we got error because there is no x train, there is no y train, there is no x test. I will be talking more about Scikit-Learn when we are implementing a project. In just few minutes, we will be implementing a project which is here. At that time, I'll talk more about Scikit-Learn. Scikit-Learn is also called as sklearn, so don't get confused. sklearn or Scikit-Learn is the same. Scikit-Learn and sklearn are the same. When importing, we'll write it as sklearn, but when we are calling it, we call it Scikit-Learn. That's all. So just as a conceptual level, Scikit-Learn contains all the algorithms like regression, classification, clustering, pre-processing, predicting, all in one single library, and that library is Scikit-Learn. We will be importing this library and we will be calling the required algorithm to run our models. Any doubt till here? Any doubts in Pandas, NumPy, Matplotlib or Scikit-Learn? Please let me know, because the next step is about Google Colab, and then we'll be diving into projects. As I promised, every week there will be few projects and one assessment to take home. Any doubts, anyone till here? In conceptual level or in practical level? Kamala gave a heads up, thumbs up. Niveda, are you comfortable, right?
Yes, yes.
Yeah.
Till now it is clear. When I see the projects and see how things are working, I think I would get still better more understanding.
Yeah, sure.
Yeah. Thank you.
Okay, then. So let's move. Okay, the next thing that you have to learn is Google Colab. I have wanted you put Google Colab here because whatever we do with till now, I'm just showcasing you like how to put the code here and how to run it. So you don't require the knowledge of entire Google Colab till now. But for the projects that we are going to do, you have to know what settings in Google Colab that you have to use and what are the powers of using Google Colab. So now, where are we going to run all this code, all the projects that we do? Google Colab is essentially a hosted Jupyter notebook environment in the cloud, in the internet. It runs Python in your browser, so you don't have to install anything on your laptop. Monesh, then why did you ask us to install Python yesterday? Because as a AI ML engineer, when you are learning something, it is better to run Python in your local, and it is better to do projects in your local, so that you will get good understanding with VS Code and all. But since we are in the beginning stages and I don't want some of you to run the code in few seconds and some of you to run the code for minutes and minutes of time, just to have a balanced environment, I have selected Google Colab. It comes with the scientific stack pre-installed. Example, like NumPy, Pandas, Scikit-Learn, all these things, if you are running it in local, you have to install them. You have to install NumPy, you have to install Pandas, you have to install Scikit-Learn, which is a good thing. You will come to understand how to install pip install NumPy, pip install Pandas, pip install Scikit-Learn and all. But in Google Colab, you no need to do all of those things. They it already, all those libraries are pre-installed. You no need to install them. You can just use them directly. And the main use of using Google Colab is its GPU and TPU runtimes. If you come here and you click on runtime, here you will see an option called change runtime type. Click on this. Here you will be seeing a wonderful options, like whether you will be running with Python 3 or R or Julia. Julia is one more programming language. So I select Python 3, and here the beauty lies. Whether you want to run with the CPU of Google Colab or whether you want to run with T4 GPU. T4 GPU. Usually T4 GPU and V5 E1 TPU are costly, but in I think they give it off for free access in Google Colab. You can also use H100 GPU, G4 GPU, A100 GPU and all, but these are some premium GPUs and very fast. So the basic one is T4 GPU. I suggest all of you to please convert your change your runtime from CPU to T4 GPU. Do it right now. If you are using Google Colab in this class, just click on runtime, click on change runtime type and select it to T4 GPU. Click on OK, click on save. So automatically it will be converted to T4 GPU. Why, Monesh? Why are we using T4 GPU? T4 GPU is much more faster, much more powerful when compared to CPU. So, and whatever the projects that we will be dealing with going forward, it is better you convert to T4 GPU because the execution's time will be faster. So convert to T4 GPU. And runtime, always put it as latest recommended. Save. And it auto saves notebooks to Google Drive, easy sharing and collaboration. Let's say you're working on a very important project and suddenly your laptop turns off. It happened to me a lot of times when I'm working in local, in like 3-4 years back, when I'm using a very old laptop for executions. It happened to me a lot of times where the laptop gets stuck or laptop suddenly switches off. And this happens in ML projects. Why? Because the computational power required for doing ML projects is very vast. You need a very powerful GPU, you need a very powerful CPU. Whatever the projects I was doing a few years back required a lot of computational powers which my laptop couldn't handle. And when I simply executed them, what happens is, like, after 1 hour of execution, suddenly my entire laptop just freezes. It just freezes there. It doesn't, I cannot move my mouse, I cannot open task manager or anything. Just the computer freezes there. And all I have to do is turn it off manually. Hold the power button, it switches off and I have to turn it on, and all the code that I have done would be gone. Most of the times it happened to me. So this Google Colab saves that. Google Colab has an inbuilt auto saving feature. So whenever you write a new cell, automatically every few seconds your Google Colab saves itself and it will be stored in your Google Drive. You can see that button here. You see here all changes are saved. So your saves are up to date. Now if suddenly network goes off, your computer gets stuck, your entire system turns off, it doesn't matter. You turn it on, go to this link, all the data, all the code, all the executions will be stored. So you can just resume your work. And this is one more reason why developers use Google Colab. So you go to this link and you sign in with Google, click a new notebook. That's it. You're instantly into Python and ML environment in the cloud. And I already spoke about Colab with local Jupyter. Local Jupyter, you install the Python, you manage environments and everything. runs on your machine, you have lot of control but also more setup, and you are limited for your hardware. You are limited by your hardware. Usually when I take a very long course, let's take because in the past I have taken like 1 year of course, I have taken 1.5 year of course. When there is a very long stretch time, I usually go with a local Jupyter, because local Jupyter, you tend to get, you tend to experience a lot of difficulties, and you have to experience difficulties to learn more. So you get to experience the difficulties of setting up an environment. You get a difficulty on setting up and managing the environments, how your hardware puts a cap on your capabilities. You'll be understanding these kind of things. But since we don't have like 1 year, 1.5 year to work on things, and we want to do things which are useful for us, so we are using Colab, because nowadays no one is setting up a local environment. Since AI came, since a cloud provides everything to you, in the work also no one uses local Jupyters no more. In lot of companies also, they just shifted to cloud systems. You will be given AWS access to work on cloud Jupyters, or you will be given access to Collabs. Like there is only few percentage people left who do it in local Jupyters nowadays. So since we are doing a smart work here, we shifted to Colab. Colab has a ready-made environment in the cloud. Open a browser, sign in, and you're ready. Great for teaching, great for experimenting, great for collaborating. For this course, Colab gives us a common environment. Everyone gets the same Python, the same libraries, and no, it works. It works on every machine. Even if you are using i3, it works for you. Even if you are using i9, it works for you. You have a graphic card, you don't have a graphic card, nothing matters here. Everyone will be in the same pace. Okay, this live demo I have already shown you, but for your reference I have put here. You can go to this, click on new notebook, rename it to our AIML class 2, put hello from Colab, and that will be executed. Let's start our first project. The first project that we are going to do is iris flower classifier. Iris flower classifier. This is a very popular data set. Iris flower classifier is a very famous data set. You can even search it in internet. Iris flower classifier. And this is one of the drawback of using Comet, by the way. Even for simple things, it tries to understand it and give me something more. I think I have to change the... And I've selected model Claude Sonnet 4.6, so that also creates a problem. This is for complex tasks, Sonnet and Opus. Oh my god, it's taking more time. Yep. Okay, so as I said, iris iris is a plant, and iris dataset is a very popular dataset, very huge, very popular. It has become so popular that Scikit-Learn has actually put it into its own code. For iris dataset, you no need to go to internet and you no need to get any dataset. No, that's not required. You can simply call iris, and iris will be downloaded from the Scikit library. That is how popular iris dataset is. And Monish, what is this Kaggle? Why did you go to Kaggle? What is this website? every ML engineer, you have to know what is Kaggle. If you don't know what is Kaggle, you are not an ML engineer in the first place. Like how JavaScript developer should know about VS Code, every ML engineer should know at least about Kaggle. Kaggle is a website that has a huge collection of data sets of different categories, different areas in life. You want flower dataset, go to Kaggle. You want school dataset, go to Kaggle. You want government dataset, go to Kaggle. Kaggle will have dataset for anything, for everything. You click on datasets, you will see a lots and lots of dataset. Netflix dataset, Amazon dataset, Corona dataset, heart disease dataset. Any dataset you can think of will be in your Kaggle. There is also one famous website called Hugging Face, which I'll be talking about Hugging Face in the later classes. But for this class, your takeaway is Kaggle. Explore Kaggle after this class. I'll give the website as well. If you have time, please explore Kaggle. Create an account in Kaggle and explore it. Okay, coming back to the project. Iris flower classifier. So I will be not diving deep into supervised learning and all that comes for the next week. But we will be using a classic supervised learning data set, and it has 150 examples, and I think it's even more. From what I know, when I'm creating this presentation, I know it's 150 the columns, but I think there might be a chance of more. And yeah, there are 4 numeric features like sepal length, width, petal length, and width. 3 classic species like Sethosa, versicolor, some Virginia, maybe I'm not pronouncing it right. And our goal of this project is to learn to predict species from the measurements. Our goal of this project is we will learn to predict species from the given measurements. When I copy the code, you will get it more better. So why we are picking only Iris? Why not other data sets? Iris dataset is very clean and it's very small. It is very beginner friendly. It's easy to visualize and understand the Iris dataset. It is very fast to train. It is very fast to evaluate, and it's ideal for live coding. And it's also widely used in intros, and whenever in any YouTube video you see, if anyone wants to teach ML models, the first thing they go for is Iris dataset. So that is why I am also picking Iris dataset. It's a very simple dataset. Okay. Now let me copy this code. This is our first simple project, by the way. Go here. Paste it and execute it. First I'll execute it and I'll show you how it works and what it does. Okay, so if you see here, I have done few things. From Scikit-Learn.datasets, I imported load Iris. This is how I get the dataset of Iris. Iris dataset is there, right? This is how I import the dataset. Scikit-Learn is nothing but your Scikit-Learn. Your Scikit-Learn is nothing but your Scikit-Learn. Scikit-Learn.datasets, and from the datasets you will be importing load Iris. Monish, how will I know that load Iris is in Scikit-Learn.datasets? It comes by practice. That's all. There is no rule or anything like that. By looking at different codes over the time and doing a lot of projects, automatically you will come to know that Iris comes from the Scikit-Learn.datasets. Or else if you don't know how to get datasets and all, you can go to this website called Scikit-Learn. You can go to this website called Scikit-Learn, and here you will have the API and the user guide. Here you have to search for Scikit-Learn.database. Where is it? Datasets, yeah. Scikit-Learn.datasets, and in the dataset you have to look for Iris. See, load Iris. So Scikit-Learn datasets contains all this datasets, and usually what I tell to my students is read documentations. That is the best thing you can do. Many of our friends ask me like what are the good references that I can learn something from. Whatever I have experienced so far, whatever knowledge I have, what I can tell you is the best resource is always the website's documentation. Nothing can beat it, because any website you take like Geeks for Geeks or Java T Point or anything, or even me or even my classes, we all take it from somewhere else, right? Geeks for Geeks takes their documentation from somewhere else. Whatever I teach is from my own experiences and my own knowledge, but we all take from this documentation. This is the truth, this is the source of truth. So nothing can beat this documentation. They don't take it from somewhere else, because they are the people who built this. The developers who built the code are the people who write this documentation. Nothing can beat this documentation. This is the source of truth. So whenever you want to learn something, like if you want to dive deep into Pandas, go to Pandas website and read the documentation. If you want to learn about Scikit-Learn, go to Scikit-Learn's website and read the documentation. Nothing can beat it. So sklearn has a lot of methods, and sklearn dataset has all these kinds of datasets, and in that I'm using load iris. And I myself have read a lot of documentations, and that is one way that I know that load iris comes from sklearn datasets. But it takes a lot of time. Over the years you will be mastering that. Now from sklearn.model selection, this train test, we need train, test and split. Again, more about train, test and split, more about classifications I'll be teaching you in the next class. This is just the introduction. I'm just giving a hint for the next class, for the upcoming class. I'm just giving you a spotlight. I'm not going to dive deep. In the next class we are going to cover what is train data, what is test data, why are we splitting it, what is classification, and why are we doing classification problems. This all comes in the next class. I'm just putting them in the spotlight now. So from sklearn.model selection, I am importing something called train, test and split. And from sklearn.neighbors, I am importing kneighbors classifier. Kneighbors classifier. And if you see properly, I'm not using any one of them. I'm not using any one of them. This is just to showcase. This is just to show you that there is something called train, test and split. There is something called kneighbors classification. There is something called accuracy score. There is something called classification report. And we'll be importing all of these from these libraries. sklearn.datasets gives you load iris. sklearn.model selection gives you train, test and split. sklearn.neighbors gives you kneighbor classification, which is a very good algorithm for classification problems. sklearn.metrics will give you accuracy score and classification report functionalities. These are used to evaluate your model. And we are importing Pandas as PD, Matplotlib as PyPlot as PLT. So iris equal to load iris. When I do iris equal to load iris, the data set is loading into iris. Let me print iris for you. You see this data, right? You see this, all the data here. All this 5.1, 3.4, 1.4, 0.2, all this data. The data is nothing but your iris data, which is huge, like 150 around. The capital X is your features and Y is your labels. Features are nothing but like what are the columns, what are the columns that are present in your data. So in my data I have length, width, petal length and petal width. So let me show you what is a sepal mean. Sepal of a flower. You see this green color stem part right here at the bottom. This one, the bottom part. This is called a sepal. Maybe I'm pronouncing it wrong, a sepal or a sepal something. This down part is called the sepal or sepal, and you know petal, right? These are the petals. This part is the petals. So based on the given length of the petals and the sepal, we will be predicting whether it is setosa or these three things. In these three, what it may be, that is what we will be predicting. And feature is the columns that gives us the data, and the target is what we will be predicting. What we will be predicting is your target. So if you think of a class, features are the hours studied, age of the student, class of the student, name of the student. These all are the features. Target is the score. Target is the score. So that is how you separate feature and target. Target is what you are predicting. For example, in a given class, you are predicting scores or something like you are predicting pass or fail. Then target becomes your pass or fail. And target usually is only one column. Only one column. These three belong to only one column. Don't think there are three different columns. These three are only one column. And feature names are different columns. These are types. In the same column, different types. So capital X always represents, again this is a coding standard, you can name it anything. Capital X always represents features. Small y always represents target. Remember that. Target in the sense labels. You can also call it as labels. Labels or target. Remember that part. So iris.data will give you the features. Iris.target will give you the prediction value. What you want to predict. Now we'll quickly explore it. So step 1 got completed. Step 1 is importing the data and loading it. Let's put a text. Step 1 is importing and loading the data. Now let's go to the step 2. Quick exploration of the data. We are exploring the data now. How do we explore the data? Using data frame. We imported, right, on the top. Here we imported, right. With that we will be exploring the data. So df equal to pd.dataframe that I've shown you, and we are taking x as columns of iris.featurenames. Iris.featurenames is this columns, and iris.target will be your prediction value, that is called species. We are giving the name it as species, what species they are, and we will be doing df.head, df.describe to describe the data. Here you will see the actual table, and also let me show you the table here. Oh, actually it is shown here. Yeah, I think this you can see it here. This is what iris data looks like. The first column is ID, sepal length, width, petal width, and species. You see species at the right side, this one. So species has only 3 unique values. Setosa, or the 3 values that I have shown here, right? These 3. So these 4 are the features, important columns to get the predicted value. This is the column that we want to predict. Let's say you are a flower engineer, and you got the data of sepal length, sepal width, petal length, and petal width, and your job is to predict what kind of flower it is. That is your job, and that is what this project is. We are getting the flowers length of petal and sepal, and we are predicting, as an engineer, we are predicting what kind of species it is. So we have segregated, as I said, iris.featurenames will give you the feature columns, iris.targetName will give you the target columns, and this is inbuilt. You are not doing anything here. Inbuilt in the library itself, iris.data, iris.target are separated. You are just using them. And we are doing df.head and df.describe to describe the data. the next part is trains, test, splitting and training. But before that, anyone any doubt in this till here, like what we did till here? Any doubt? Just like a small recap, we imported all the required libraries. We imported iris dataset, and iris.data automatically, again we are not doing anything. Iris.data will give the all the feature columns, that is the most important columns. Iris.target will give you the column that we would like to predict, and we are putting iris.data columns into capital X. We are putting iris.target into small y, and this is the coding standard. Capital X and small y is the coding standard. We are printing them. X dot shape will give you the number of rows and columns in that X. Y dot shape will give you the number of rows and columns. You can see 150 rows, but there is no column. I mean comma, after comma there is nothing, means it's only 1. After comma, if there is nothing, it represents 1. So 150 rows, only 1 column. And we are getting the feature names. Iris.feature names will give you the all the column names. Iris.target names will give the target names. And we have converted that entire feature names that is the 150 rows and 4 columns into a data frame, and we have moved this entire target names into one single column called species. And then we have done df.head and df.describe to understand the data. Next step is your training, test, splitting and training. Okay, Monish, what is this? What is this capital X train, capital X test, small y train and small y test? I'll explain to you what is this for in a very simple terms with a real life example. X train, X test, Y train, Y test. Okay. Or else let's segregate in this way. X train, Y train, X test, Y test. Okay. All of us, I'll give you a real life example so that you will understand X train, Y train, X test, Y test better. All of us, we all prepared for exams like 10th board exams, 9th class exams, 8th class exams, intermediate exams and all. We all would have used a common pattern. What that pattern is, we will read the question and answer, like after reading the concepts there will be a few questions and answers in the textbook or in our notebook. Like you will be having some sample questions and answers, right? Like 150 questions and answers that we'll be preparing, and from that only 10 will be coming to the exam. So we all would have done that. So how do? We'll first read the question and the answer. For all the, let's say there are 20 questions and answers, we will read all the 20 of them. After reading all the 20 of them, I don't know if anyone have done this. After reading the question, you will put your hand on the top of the answer and you will try to recollect the answer. You're getting my point, right? After reading the question and the answer, after by-hearting it, you will put your hand on the top of the answer so that you will not see the answer visually. And you will read the question and you will try to recollect the answer. You will try to reframe the sentences in your mind and you try to recollect it. We all would have prepared in such a way at some point in our life. The same concept applies here. The same concept applies here. So there will be X train, Y train, X test and Y test. So what happens is, in X train and Y train, the model gets trained. The model gets trained. So in the or else I'll print it here. Print X train, comma, Y train. And for now, I don't need this and all. Okay. So I got the X train and I got the Y train, this one. So what happens is, now the model starts to learn that if it is 4.6, 3.6, 1 and 0.2, then it belongs to 0. 0 means this one. This is Setosa means 0, versicolor means 1, Virginica means 2. So 0, 1 and 2. Okay. So what model learns is, from X train and Y train, 4.6 and 3.6, 1 and 0.2 means 0. And 5.7, 4.4, 1.5 and 0.4 means again 0. So like that, it will try to see the pattern. It will try to see the pattern in it. Till here, did you understand like what X train and Y train are doing? X train and Y train are like the actual questions and answers, like important questions and answers before the exam. They are like the important questions and answers before the exam. The questions and answers are already given to you, important questions and answers, and you are just by-hearting them. Did you understand what is X train and Y train? If not, let me know. I'll try to come up with a better example.
Yes, I got it.
Okay. If any doubts, yeah, please let me know, because X train, Y train, X test, Y test are very important. So again, these are like the important questions given before the exam, and you are by-hearting them. You're by-hearting the question. Again, there is a small note here. You're by-hearting the question and you're by-hearting the answer as well. You're not only by-hearting the Y train, you're by-hearting both. You're by-hearting the question and you're by-hearting the answer. Now, after doing this, Monesh, then what is X test and Y test? Print X of test and Y, sorry, small y of test. This is like the mock test before the actual exam. X test and Y test are like the exams that is conducted by your parents before the exam. Sometimes our mother or father will be sitting and they will be asking us question from the notebook. Like from the important questions, like they will be picking one question and they will be asking that question and you have to answer them. Even if you answer them correctly or wrongly, at the end it doesn't matter, because your marks in the exam matter. Here just you are learning. This is the part of learning. You will be answering to your parent and your parent will be correcting you. Whether if you say whatever you said is right or wrong, your parent will be correcting you and you will be relearning it. So a process goes on and on and on, like a mock test before the actual exam. Again, I'm saying X train and Y train is your important questions and answers given by your teachers, where you will be by-hearting. Question is in front of you, answer also is in front of you, you're by-hearting. X test and Y test is like a mock test. Question is only in front of you. You are only seeing the question and you're guessing the answer, or you're predicting the answer, or you're telling the answer, something. And you will be getting a reward of negative or positive in this particular step. If it is wrong, the teacher will tell, I mean, the mock exam will tell you you are wrong, or the parent will correct you. So here you will be relearning. Did you understand the difference between X train, Y train, and X test, Y test? Here the model will be understanding both the inputs and the output, the predicted value and the given value. In the X test and Y test, it will try to do a prediction. It's like a mock prediction, not the actual prediction, a mock prediction, and it checks for itself whether it is predicting correct or not. If it feels sucks, if it feels good, then we will go for the actual prediction. So X train and Y train is the simple training phase. X test, Y test is the like the mocking test phase. Any doubts in this four? These four are very important. Again, if you want, I'll take again a half an hour to explain this, but X train, Y train, and X test, Y test are very important. So X test, Y test data will be shorter one. 80% of the original data is your train data, X train and Y train. 20% of the data is your X test and Y test. That's why I have said it as test size to be 0.2. Test size 0.2 means 2% is the test, 0.2% is the test data, which is 20%, 0.8 is the train data, which is 80%. Any doubts, anyone in this four? X train, Y train, X test and Y test? Please don't.
So what's the
Yeah,
yeah, what's the optimal ratios like when you want to like split the test and the train? What's the
0.2.
optimal you would okay, so it's more of like 70%, 30%. Oh, sorry. 80%, 20%,
Yes,
right?
80 and
Okay.
20 is the best optimal split. You can also, I mean,
Okay.
you will also see people doing 60 40 70 30. But here the
Uh-huh.
problem is if you train only 60% of data, it's like
Right, right.
in the 20 important questions, you are reading only 10 and going to an exam if you are doing
Right.
60%. So
Right.
80
Okay.
20 is like the best optimal split.
Okay. So if I don't choose within the optimal range, will that affect the like how the evaluation or like how the model fits?
Yes,
Okay.
it 0.2 will give you the best accuracy. Yeah, anything
Okay.
other than 0.2, your accuracy will be reduced.
Okay. So it goes across all the data ranges, like whatever the data set we take. We don't have to like find what's the optimal ratio is and then
No, for any
okay,
data
okay.
set 0.2.
Okay, okay. Thank you.
Yeah, and this random state 42 is also a developer thing. It's like became a standard. You can put actually any number here, but what this random state means that randomly data will be selected. If you put a lower value, it will be less random. If it is it is a greater number, it will be more random. You can put any number actually, 36, 18, 5, 6, anything, but 42 is the optimal value. Optimal randomness is 42 is what the ML developers found. So everyone started to use the same thing. Test size is 0.2 to be optimal, random state should be 42 to be optimal. And X train, Y train, X test, Y test, I said. Yeah, any doubts, please again let me know, because these four are so important for any project that we do. Yeah, and
I dived deep into why 42. It was a very interesting story.
sorry, Kamala.
No, I dived like why that particular random number is like 42, but it's a good story to why they chose 42.
Yeah. So this part is done. Yeah, I'll remove this. Oh, it's almost 6. And what I have to cover still. It's only numpy.hours and regression.fit. Okay. Yeah, few more minutes and we'll complete. Just I'll take few more minutes. So we are fitting the model, right? And okay. So I print the shape of xtrain and xtest. Then the model, the algorithm that we will be using for classifying this problem is k nearest neighbor. This is a classification problem. More about this classification and supervised learning will be coming up in the next week class. So just as a gist, like a small spotlight thing, the model we'll be using is a k-neighbors classifier, and the problem itself is a classification problem because you have a few feature sets and you're predicting. So this is a classic classification problem, and for that we will be picking up a good classification algorithm, and a very good classification algorithm is k-neighbors classifier. Again, you can use any n neighbors, but optimally again it's standard that you use 3, but you can use 4, 5, it doesn't matter. 3 seems to be a very good number, so we go with 3. So k n neighbors classifier with n neighbors to be 3, and the more the n neighbors, the more the time it takes. That is one thing you have to keep in mind. N neighbors is nothing but the number of nodes for each decision to be made in the classification. 3 is an optimal one. So you choose the model here, you're just choosing it with some parameters, and then the final training happens. Here is where the final training, the magic of machine learning happens in this one line. Model.fit. That's it. When you do model.fit, the training of the data with the model happens here. This is where the child learns to find the patterns. This is where the child learns to understand the data. This is where the students learn important questions and answers, the by-hearting part. Whatever the time or the by-hearting part is there, right? This model.fit happens that, does that. So this is where the magic happens and you get a model. I run it. You can see that happening here. Now, once the model is fit, you can start using it. How you will use it? In step 5. We will be evaluating the model. Monish, what is this evaluating the model, Monish? There is no guarantee in this entire world that your model is good. There is no guarantee. After you create the model, you have to actually test it. You have to evaluate it. Evaluate is nothing but the actual test. Again, I will link this up with a real life example. When you go to your teacher and tell that, hey teacher, I have by-hearted all the important questions and answers. I won't give the exam, just pass me. No school or college will do that. You have to give the actual exam, and you have to get the marks, and that marks is your evaluation. Whether you got first rank, whether you got 10th rank, whether you passed, whether you failed, there will be an evaluation on every single student. The same thing happens here. Since the model is just trained, we cannot just use the model. You have to first evaluate it. You have to test it. So for testing it, you use model.predict. This is where the testing happens. Remember again, model.fit is for training. Model.predict is for testing. Model.fit is where the student will by heart the important questions and answers. Model.predict is where the student gives the mock exam, not the actual one. Actual one comes later, in the final later. This is where the mock exam comes into place. We will be just getting the mock exam results. So again, I'm saying one more time, I'm repeating, model.fit is like the student preparing for important questions and answers with the training data. Model.predict is like the student giving the mock exam. Now here, if you observe, in the model.fit, I'm giving both the X train and the Y train, but in the predict, I'm giving only the X test. I am not giving the Y test. That is what I'm saying from the beginning. During the mock exam, we don't provide answers to the students. When your father or mother is asking you questions from the important questions and answers in the childhood, they won't tell you the answers. You have to tell the answers. Once you tell the answers, they will tell whether you are right or wrong. The same thing applies to the model. In the X-train, and you provide, in the training, you provide both the X-train and Y-train. But in the predict, you never provide Y-test. If you provide Y-test, your accuracy will be 100%. And if your model accuracy is 100%, definitely your model is bad. Definitely your model is bad. In lot of batches I said the same thing. That comes the problem of overfitting. If your model is 100%, you have to recheck your entire code. No model will be 100%. Some or the other, at least it should be 99.9 is okay, but 100% means something somewhere went wrong. Remember this part. So don't provide Y-test, only provide X-test, and it starts to predict. You will be doing the accuracy score. Now here the magic happens. When I'm giving the accuracy score, observe carefully. I am giving the Y-test, which I have not given here, and I'm giving the Y-pred. I'm giving Y-test, I'm giving the Y-pred. What it means is, I am the teacher, and I am correcting the mock exam of the student. As a teacher, I have to know the answers. So accuracy score is the teacher here. For the teacher, we are giving the actual answers from the important questions and answers. We are giving the actual answers, mock exam answers, and we are giving the student's answer. We are giving the student's answers. Y-pred is the student's answers. X-test is the mock exam questions. Y-test is the actual answers, actual mock exam answers. So the teacher takes the actual mock exam results and student answers, and he starts to correct the paper. And that result will be your accuracy. That will be your accuracy. Now if I run it, the accuracy is 1.0. I will tell you what is precision recall and F1 score in the coming up class. I don't want to fry up your brain now. Yeah, all of this, what are these metrics, I'll tell you in the upcoming class. So the accuracy is 1.0. The accuracy is 1.0, which means the accuracy is so good. It is so good. Still we have not done the actual prediction, but it is so good. All of these are 1.0, but the support is 9 and 11. 9 and 11 in the sense total it got is 10, 9 and 11. If you add them, you'll get 30, which is the trained data. So what I observe is that here the model that we are using is 100%. Now you ask a question, Monish, just now you told in real life if you get 100% in a model, it might be wrong. In this case, it is okay, because the data set that we are using is very clean. The data set we are using is already from a library which is very trained, and you see this k-neighbors classifier, right? This algorithm also is built on, it's created by using this one of these data sets. So since the algorithm already knows about this data set, it simply predicted all the right values. So in this scenario, it is fine. In this scenario, it is fine. It is totally fine. I'm talking about a real life scenario. In a real life scenario where you take the data from outside world and you build your own models, and that time when you get 100% of accuracy, right, you have to recheck your work. My suggestion is always to recheck your work. If you get 100%, something might be going too good or something might be going too bad. So as a note, but here it is fine because the data set is already pre-built, the model is pre-built on top of it, so that is fine. And we are printing the detailed metrics. Classification report is like your report card of your mock exam. Report card of your mock exam, like which question you got it right, which question you got it wrong. All of this is your classification report. So yeah, any doubts still here? In all the 5 steps that we have done, we have imported and loaded the data, we have explored the data, we have converted into train and test, we have evaluated the model. That's it. Any doubts still here? Anyone? Yeah, one more time. I mean, before going forward, any doubts, anyone? I know we are over the time. I'll end up soon. It's almost over. This next project will be, I mean, I'll just explain it, and it will be like a takeaway assignment. Any doubts on the project one? Anyone? Any doubts? Okay. Okay, then let's do an actual prediction fast and let's wind up. New flower uh, equal to, let's pick 5.0. Let's just give some values quickly. 3.3, 1.5, 0.2. Model.predict new flower, predicted species, iris.target names, predicted index of 0, I guess. Yeah, index of 0. And print, I need the measurements. Which will be new flower of 0, predicted species will be just predicted species, right? Correct. So now what I'm doing is, now I'm giving the final exam. I'm giving the I'm making the student to give the final exam. We are giving new flower lengths like 5.0, 3.3, 1.5, 0.2, and we are asking the model to predict for this new flower, to predict to this new flower, and that prediction should come from the predicted species. So it gives us some value, right? It gives us 0, 1 or 2. That 0, 1 or 2, I'm putting it into target name so that I'll get the actual target name. Now if I run it, it is Setosa. So the values that I gave, my model is predicting that it is Setosa. So that is how we make model, and that is how we make it to give the mock exams, I mean from the train and test, and that is how we make the model to run it on the real data. So we gave a new data and we got a new output with the model. That will be the end of project 1. Any doubts, anyone, before I wind up? Project 2 is nothing but, instead of using a classification algorithm, we are using a regression algorithm, and we are using study hours. We are giving the students data and we are getting the study hours. And this part I'll be sharing it in the in the WhatsApp group, this HTML, and this is your takeaway assignment. Try it to do it on your own. The code is also given here, so no need to worry for that. And let me know if you are facing any problem. So any doubts, anyone?